2. We have a piecewise defined function, and basically on this one, you just got to make sure you're looking at the right spot. Okay, so before I start, we're only going to go between -2 and 1. If an x value is between those two, inclusive of -2, not inclusive of 1, we're going to go here. If x is equal to 1, we go here, and if x is greater than 1 here. So this first one says f of 0, well 0 will fit right between -2 and 1. That's where it's going to go. So what do? We plug it into this part of the function. So basically that's equivalent to x plus 3, or 0 plus 3, which gives us a value of 3. F of 1, well, what do? We got to plug it in wherever 1 fits. 1 fits right in the middle here. It's a constant function there, so we have a y value of 5. And then f of 4 likewise is going to get us into this bottom part of the function. So we would have the opposite of 4 plus 2, which obviously is -2. So those are the three answers to number 2. Pretty straightforward there. Number 3 now. Let's look and practice some more with these piecewise functions. One thing, this isn't going to be perfect on this. It's kind of hard on the video, but I'll try my best. One thing that kids are having that's helping some of them is to lay out your intervals with vertical lines first. So we're definitely doing something at the value of x of 2. So I'm going to just kind of go like this and understand at an x value of 2, that's splitting this graph into 2 different regions here. Okay? Something is happening when we have x values greater than or equal to 2. Well, that's this region over here. Everything over here to the right is going to have x values bigger than 2, and on this line is or equal to 2. So that's a constant function of 5. So we go 1, 2, 3, 4. Let me count this right. 1, 2, 3, 4, and then right there is 5. So try to keep it straight here, every value to the right of 2, as far as x values go, they will have a y value of 5. All right, and then the next one here is literally saying y is equal to x minus 3. Well, that's a line with a slope of 1 and a y-intercept of 0, -3. And we're only doing that less than 2 for x values. So we're going to start by graphing in this region here. We're going to go down 1, 2, 3, make our point. And then the slope is 1. So up 1 over 1. Down 1, left 1, down 1, left 1, down 1, left 1. Okay, so, but up 1 over 1 now, we are not including the x value of 2. So when we go up 1 over 1, there's going to be an open circle right there. So then we would graph this way. So that's our piecewise defined function. Okay, so now they're going to ask for the domain and range. So domain would be all the x values that could possibly work. If we go left to right, every x value you can think of will produce a y value, even at 2. At 2, we do have a y value in everywhere. So the domain for this one is going to be -infinity to infinity, because every x value that you can think of will actually produce a y value. The range is a little different story. If we go down to up, always go smallest to biggest, we are going to hit -infinity. There will be ordered pairs continually to get smaller as far as the y values go, all the way up to -1. We will not have an ordered pair with a y value of -1, so we got to cap that off there. But there's also another y value, only one, and that's 5. Okay? So we've got -infinity, -1, union 5, and life is good. X-intercept, there is nothing. Nope, there are no x-intercepts, and then the y-intercept is clearly marked as 0, -3, as talked about. Okay, so now this one here, we actually have 3 sections to talk about. So taking it to the next level here. Basically, we have something going on from -2 to 2. So I'm going to break this up from -2 all the way to 2. And then we got to think about something going on to the right, middle, and left of this, which is fine. We can handle this. All right, so let's just start at the top. 3x. That's if we have it happening right here. Well, that's between -2 and 2. So this has a y-intercept of 0. So our first point is going to be right here. And then we're going to go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. And I have to put an open circle there because it says less than, not less than or equal to. And then we go down 1, 2, 3 over 1, and we go down 1, 2, 3 over 1, and we put a nice solid dot because it is or equal to there. I wish I had a straight edge here, but I will connect the best of my ability on this. Not bad. So that's what's happening in the middle. Let me switch colors to blue here. There's something happening over here when x values are greater than or equal to 2. All right, now watch this. You got to be very careful here. You got to be like, okay, we got to graph this, but it gets confusing. So that's why I suggest you just do it in pencil and then erase. But we would start up 1. That's the y-intercept. So I would start up 1, and I would put, if I were graphing, I would put a point here. And then I would go down 1 over 2. I would put a point here. And then I would do that. But I can't mark all that up on my graph. So I am going to think about starting here, down 1, right 2. This is or equal to. So I'm going to actually start my line at that point, down 1 over 2, down 1 over 2, and I would continue in this direction forever because its x value is greater than or equal to 2. And then switch to black here for less than negative 2. So over here we got a constant function, which is nice. So it's constantly 3. So 1, 2, 3, open circle because it's less than, and then just continuing in that direction. All right, so looking at our domain, left to right, we will have values, we will have values. Ooh, we do have a value, we will have values, we're going to have everything. Every x value will produce a y value. You can also kind of look here to understand that. The range, the lowest this graph is going to get is 1, 2, 3, 4, 5, 6, negative 6. So negative 6 is the lowest this graph gets, and I do have, oh wait, look at this section of the graph. Isn't this going to continue to go down forever and ever and ever? So it's not just right here. We will actually have negative infinity as far as the left part of our range. Good, or down part. So negative infinity, now that'll go all the way up to here, and then this one takes care of it all the way up to there, but we won't ever get above this point because that's a constant one there. So basically we're going to be at 1, 2, 3, 4, 5, 6. So we're going to go negative infinity to 6 with a parenthesis there. X-intercepts, there's actually 2 of them. There's one at the origin, and then there's one at 2, 0. And then the y-intercept was just talked about at 0, 0. Okay, hope this helps.